I'd like to introduce our next speaker, David Dorff, who will be talking about exceeding customer expectation with machine learning. David is a worldwide retail specialist at AWS, where he assists retailers with commerce strategy. Before he joined AWS, David developed retail technology systems at a plethora of companies, including Infor Retail, Oracle Retail, 360 Commerce, Circuit City, AMF Bowling, and Schlumberger Retail and Vision. David spent several years working with the NRF Arts on technology standards, and he continues to support the Retail Orphan Initiative charity. He holds a degree from Virginia Tech and Penn State. Please give a warm welcome to David.
Hello, everyone. Thanks for that warm welcome. Yeah, Schlumberger is a tough name to pronounce. It's a German company in France. They worked on smart cards. So I helped bring the chip cards that you have in your credit cards to the US market and pushed it around the world. Anyway, thanks for having me here today. There's nothing I like better than talking about retail. I've been in the retail business for over 25 years now, and I absolutely love it. I hope you were able to attend yesterday's workshop put on by my colleagues, Sarah and James. And I hope that satisfied your inner geek, because I'm going to really be focused on the business side and the outcomes that machine learning can drive for retailers. So we're not going to have any three-letter acronyms. We're not going to be dropping professor names. There'll be no mathematical formulas requiring superscript. We're just going to be talking about customers and use cases. So first off, let me talk a little bit about AWS. AWS was born from retail and built for retailers. And this obviously comes from our Amazon heritage. 20 years ago, we began developing many of the innovations that are being shared with our customers today. And we've been customer obsessed from the beginning. That's one of our leadership principles you may have heard about. Our early leadership with cloud allows us to offer retailers something truly rare, and that is a head start. We've been sharing features, price decreases, performance optimizations, security know-how, even some of the advanced capabilities underpinning our Amazon.com site with retailers across the world. And so as someone who spends all day talking to retailers and thinking about solutions, I'd like to share some things I've learned over the years about machine learning. And don't worry, machine learning is a two-letter acronym, not a three, so we're still okay. So let's start by taking a look at what the customer really wants. So here I'm showing the major points of engagement before, during, and after the purchase. It's a customer journey. And we've identified a few of the moments of choice. Those are the things along the bottom there. And it only requires a little bit of focus to see that those moments of choice really highlight the frustrations that many customers are having and the challenges that are faced by retailers. So looking at those, 63% of consumers expect personalization as a standard, and 74% are frustrated when it's not offered. 78% of consumers are willing to leave a retailer site fast if free shipping isn't offered. And tracking details are checked by customers an average of 8 times during a typical shipment, with new updates desired each time. I know when I order something, I'm always checking back to see when it's going to arrive. 60% of consumers are unhappy with the returns process, or they're not even willing to try. And as we know, if our customers don't feel like they can return something easily, they're much less likely to purchase. So it's these moments of choice that differentiate the customer journeys and lead the happy customers to pay a 7% premium and be 8% less likely to switch to a competitive brand. And they're twice as likely to spontaneously recommend a brand that they like. So it's clear we need to help retailers deliver exceptional customer journeys. So what is it that customers want? We can summarize their expectations into 5 areas. And if you're not addressing these areas, you risk becoming irrelevant. So true unified commerce. This is an area where retailers have been working for years to try and tie their website experience together with their store experience. We know lots and lots of customers start on the web, do research, maybe start in social, maybe look things up on their phone, end up in the store because they want to touch it, feel it. Maybe they actually buy it in the store, maybe they go home to buy it online. But it needs to be a unified experience. And most retailers have grown up with siloed solutions for their in-store and online point of sale. So these become disjoint experiences and can cause friction for consumers. Secondly is confidence and trust. So customers want quality products. They want to trust that the prices are reasonable, and they want to know that they have the ability to return when necessary. Convenience and speed. Everyone is time crunched, and so customers want options to shop quickly and cut things short. We've seen this really become very popular during the pandemic when customers do buy online, pick up at store, or pick up at the curb. That integrated type of transaction has been accelerated through the pandemic. Safety and security. So customers want to feel safe as they shop. They also want to know that retailers can care about things like sustainability. So we're seeing lots of push of consumers pushing retailers and retailers wanting to make sure that they have sustainable operations. And then meaningful interactions, which is probably the most important thing. Everyone wants to be a VIP. So messages and experiences need to be tailored to them. They need to feel like their expectations are being met all the time. So now that we have a decent idea of what customers want, let's think about how we can deliver. So at Amazon, we think we've been leading the way for innovation in the retail industry. And here are some examples of what we've been working on. So the first thing there, where it says Ask Alexa, is our Ask Alexa kiosks in the Amazon Fresh stores. So we've opened some grocery chains, and along the end caps, we have these stations where you can actually ask Alexa questions. You can ask where to find particular items, and it'll tell you what aisle they're on or give you recipe suggestions, whatever you're looking for. Very convenient, and a lot of customers like to be able to do self-help. Amazon 4-star stores have been around a while. We don't do any particular merchandising. We just put the merchandise that gets 4 stars, the highest rated stuff, in the stores. Amazon Go, these are convenience stores that use our Just Walk Out technology, which we actually sell to other retailers as well. So you're going to see this coming up in an airport near you and probably some other places soon. But this is a touchless way to check out. So you scan your phone on the way in, you grab things off the shelf, and you walk out. It charges you based on the credit card you have on file and sends you a receipt. So we use all sorts of interesting computer vision backed by machine learning that can tell the intent of the user, and we can see them take items and put items back. In the bottom left is Alexa Auto. So we're already embedding Alexa into a lot of new vehicles in the US market. There's also a device that kind of takes Alexa on your phone and broadcasts it through the vehicle system. But that's becoming more important. We're doing some neat things like we have a solution with Exxon where you can pay using Alexa. So when you pull into an Exxon gas station, we know your location. You say, Alexa, I want to pay for gas. She says, what pump? You say pump 4, and it turns the pump on. You pump your gas and you pay with the card on file. Really removing friction from that whole process. The next one moving to the right is Amazon One. This is our technology to identify people using their palm print. And the one after that is a smart shopping cart with a built-in scale and a camera. Basically, it kind of does the same thing that Just Walk Out does in a grocery scenario, whereas you add items to the cart, we can see the items being added and just add them to your total. And then when you fill the cart up, you just walk out of the store. And the last one is probably the most famous one that I remember seeing on 60 Minutes in the US, are drones. So just this year, we got permission from the FAA in the US to start doing some drone deliveries in limited areas. So I do think this is going to come to a reality in the near future. And how does all this great innovation happen? Well, we use something called working backwards. It's a process where we identify a customer need, and then we work backwards to the solution. So for each of these different innovations, we actually write the press release first. We say exactly who it's for, how it's going to work, and why it's going to better things. And we have that all written out, and then we say, okay, now that we've got that defined, how do we actually figure out what the solution should be? So in the example of something like Just Walk Out, we write a press release around how we're going to remove all the friction from the checkout process and make it really easy for consumers to buy things in a convenience store. And then we sit back and we figure out, okay, how are we going to do that? We have to identify the customer somehow. We'll have them scan in. We're going to have to see them take things. We'll have to have computer vision, and maybe we'll do some things around smart shelves. And we start to build all that technology around the solution. And the interesting thing about all of these different solutions is that they're all powered by machine learning. That's the one thread that connects them all. Machine learning's been around for a long time, but what's really made it possible to do these types of things is all the compute capacity in the cloud. So when I think about ML for retail, there's so many use cases that apply, but these are the most popular. I've kind of narrowed it down to these 5 areas. And machine learning helps improve decisions and it helps automate processes. And both go a long way to delivering better customer journeys, whether it's online or in the store or post-purchase. And I'm a stores guy. My background is from store systems. So I love to see that all these different areas directly are impacted in stores. And in reality, machine learning can be applied across all the business areas, but I only have 30 minutes, so I'm gonna narrow the focus a bit down to these 5. So let's take a look at each one of them. Forecasting. Forecasting is probably the most popular area to apply machine learning in retail. So we do things like use it to reduce waste and markdowns, improve in-stock rates and inventory turns. Staffing is a huge area. You could do staffing in the store. You could do staffing in the warehouse. You could do staffing at headquarters. Planning for new products. So accurately predicting cold start products. What we typically had to do in the past was we would just pick products that we think kind of are going to perform like the new product and use their forecast as a substitute until we get some actual data. But really, if you look at it from an attribute perspective, you can understand based on the attributes and the history of those attributes what that new product does and be able to forecast more accurately for it. We can sense and demand with external factors. So the forecast has to have lots of things impact on it. One of the ones that seems to be popular is weather. So we have ways to pull in weather forecasting to be able to impact that forecast. Because obviously the weather changes the way people have their shopping patterns. And then pricing and promotions. So things like markdowns, setting initial prices and determining the halo effects or cannibalization effects of promotions. All that great stuff falls within forecasting. And not all forecasting is machine learning. So our forecasting solution provides, I think it's like 4 or 5 statistical models and 2 or 3 machine learning models. And you can choose which one of those you want to use for your particular product that you're forecasting, or you can just set it to auto and it will figure out which one applies best. So AWS customer More Retail, which is based in India, one of the largest hypermarket and supermarket chains, used forecasts to reduce food waste. So through more accurate machine learning forecasting, they were actually able to reduce their fresh produce waste by 30% and improve in-stock rates from 80% to 90%. 90% may not sound that great, but coming from 80%, 10 points is huge. Because accurate forecasting has a huge impact on a retailer's business. It's probably the most impactful. So let's take a look at the next one. Personalization. This is one of my favorite areas. We take whatever we know about a customer, whether that customer is anonymous or identified, and use it to make the experience more relevant to them. So for a known customer, we can look at things like demographics, past purchases, or any other information we have in our CRM system. And if they're not identified, or if they are identified, we can also pull in things like search history, page traversals. We can form a decent picture of what that customer is interested in. So one of the most popular things to do is to deliver a unique homepage experience. When they first log in or when they first get to that page, we want to make that experience as relevant to them as possible to pull them in. Secondly, product recommendations. So I think the first time I saw product recommendations online was back in 1998 when Amazon started doing it. We started with things like customers that liked this product also bought this product. All right, so there are many ways to do recommendations, but figuring out what the customer is looking for and then making recommendations has a huge uplift. Improved discoverability, so helping customers find the products they're looking for through search and having an impact on that search by knowing what they're likely to be looking for. Relevant product rankings, so ranking those products in categories or in search results. Enhance marketing communication. So before and after they visit a website or a store, we may want to send them an email and let them know about promotions or other products that they might be interested in. If we must make those relevant to them or they become spam. So using personalization in combination with marketing allows us to have a much more targeted offer that's much more likely to be relevant to that customer. And then boosting upsell and cross-sell. Again, you bought this, others were interested in this. You can start to get people to pull on that thread and start to buy more of what you're selling. So a great example of this is Pomelo, which is a fashion retailer in Asia. It's a startup that has a global mindset. They're very trendy, on the go. They serve customers all along Southeast Asia with stores in both online. And they increased their gross revenue from category pages by 15%. And they receive about 60% of product views are fueled by Amazon recommendations. So it's a huge part of their online offering. And actually, they've unlocked an 8% increase in incremental gross revenue through the use of personalization across their websites and across their marketing. So really great story. Fulfillment. The first thing I want to say is, if you ever get a chance to visit an Amazon fulfillment center, please do. The tours are phenomenal. And right now, because of the pandemic, we're not doing those. So you can go to YouTube and look for Amazon Fulfillment Center tour with AWS. It's 11 minutes. You'll be blown away by the amount of machine learning that actually goes on in the fulfillment process. For example, many retailers have implemented cross-channel fulfillment scenarios, but it's often at the expense of margin. So being able to fulfill effectively and efficiently is crucial to maintaining a profitable business. So we use lots of ML here. For example, as we're stowing things in bins, you would think that the bins would have related items. They do not. We have found over the years that you want unrelated items in those bins because you don't want people to accidentally pick the wrong ones. So we actually use machine learning when we're doing put away and pulling things off of a pallet and putting them into the bins. We use machine learning to show what bins not to put that in. We don't want things that are similar to each other to be in the same bins or near each other. And we want to make sure the weight distribution of the bin is correct. And so machine learning helps make sure that those get stored in an efficient way so that they get picked more efficiently. And on the picking side, we have robots called Kiva robots. They're kind of like Roombas on steroids that pick up shelves full of these bins and move them to the pickers. So we don't have pickers running up and down the aisles of a warehouse. And they move them to the picker and they light up the bin that they should pull from. And there's a picture of the item that they're pulling and quantity. We make sure it's as efficient as possible in this picking process. And then box selection. So we use machine learning to determine, based on all the things that are going to go in this order, what is the most best fitting box, cardboard box that should be selected. Which, by the way, I occasionally get boxes that have a lot of air in them, so we're improving that algorithm a bit. But it saves a lot, and sustainability is hugely important to us. And then that box may be the entire order. It may just be part of an order. So we use machine learning to determine whether we should combine a product from a different fulfillment center and have it transferred over, or whether we should send two separate packages to the customer. Machine learning determines whether we do that, and it also determines what carrier we pick. Are we going to send this by air, by freight, by third party, and then the delivery routing itself. So there's a ton of machine learning that goes into the fulfillment process. Along those lines, we have a customer, Ocado, in the UK that was a pure play grocery retailer for online, and they've actually built their own set of robotics for fulfillment that they sell to other grocery retailers. And their growth has been 27% in the pandemic amongst grocery. It's a fantastic use case. They have a incredible set of robots. And you're going to start to see in the future grocery stores where the upstairs levels are robots that are doing fulfillment, as we do more and more buy online, pick up at the store, or have delivered. So part of that fulfillment was the use of computer vision. So today we can use things like facial recognition. However, I don't think society is quite ready for that, even though the technology is. So we've set that aside, but we're doing some really cool things with people counting. So it's not just counting the number of people that come into a store, it's understanding demographics, knowing that a mother and her 2 kids is really one shopper, understanding how many are men, how many are women, approximate ages. All that information can go into optimizing the store layout and the marketing and the assortment of product in the store. We use heat maps to understand where people are spending their time in the store. So again, we can start to optimize the store for better flow, or get people to have better marketing in certain areas to get people all over the store. We're even doing things like personal protection equipment validation if you want to make sure that people that enter your store are wearing a mask. I talked about in Just Walk Out using intent. So understanding when an arm rises up and takes a product off a shelf and puts it in a basket, we can see that. Safety, so when there are spills, detecting those immediately and alerting staff to clean them up before there's a lawsuit on our hands. Computer vision has come a long way, and it's because of machine learning that makes this possible. So Canada's largest independent convenience and fuel retailer is Parkland. They have several different brands, about 2,700 stores, and they're using existing cameras, 5 to 7 cameras per store, inside the store and outside the store, to start doing some of this. So they're going to do people counting and heat maps to try and optimize the experience for their C-store customers. Okay, let's move on to our last topic, which is optimizations, which is a very general area. ML is great for optimizing the decisions we make every day, like setting prices, doing markdowns, or allocating product. We can also optimize things like labor scheduling, shipping, and assortments. My first experience with markdown was with Oracle. We acquired a company in the Boston area that did markdown optimization. So what happens is buyers get very enamored with the things that they buy. This is merchandise buyers. And so they tend not to mark them down fast enough. You want to have a perfect cadence where you've marked down your item, you're not leaving any money on the table, you're not over promoting, but by the end of the season, you're out of that particular thing, because nobody wants to try to sell bathing suits in the middle of December. So markdown optimization is a huge area. I mentioned labor scheduling earlier, and assortments are huge as well. River Island, which is a well-known fashion retailer for about 65 years now in the UK, they use machine learning to make better decisions. They can quickly and efficiently prioritize stock across channels for allocation and replenishment based on where they have a higher likelihood of being sold. So instead of relying on overgeneralized clustering or aggregation, they're doing it very specific to each selling channel. And this led to a 23.7 improvement in stockouts. So overall, they reduced their lost sales by a little over 14% using machine learning. Great story for them. So just in the 20 minutes I think we've been talking, we've gone through 30 different use cases for machine learning in retail. And there's a huge opportunity. We saw 5 customers that are doing it really well. I think this is just scratching the surface, but there's all sorts of opportunities in retail to apply machine learning to optimize those decisions and processes. So just for a second, if we take a look at the AWS machine learning stack, it's really in 3 layers. So at the top is our AI services. So these are our highest level services. These are typically managed services like Amazon personalization that are very easy to use. They have lots of algorithms. It can select the algorithms on its own, or you can tell it which algorithms to use. But they're very simple to use. You don't have to be a data scientist. Moving down to the ML services, we have a generalized machine learning product called SageMaker, which gives you a lot more control, but it still has all the built-ins available for you in an IDE. So you can do all your labeling and building your models and a lot of the work yourself, but you still have all the tools at hand to make it very efficient and fast. And then at the bottom layer is our frameworks and infrastructure. And this is for the true data scientists that want to roll up their sleeves and know every little detail. You can use things like TensorFlow, MXNet, and PyTorch, deploy those out on the cloud and run them yourself. And what I think is interesting about this stack is the fact that Amazon or AWS provides specialized chips to be able to optimize all of these machine learning workloads. So Amazon Elastic Inference allows you to attach low-cost GPUs powered by the acceleration to Amazon EC2 and SageMaker instances. And there's also Inferentia, which is our particular chip that handles that. Trainium is specialized for training models. We're continually improving the GPUs and CPUs that we use to make them even faster. So this gives a real competitive advantage to those that are doing machine learning in the AWS cloud. Okay, so the last thing that I want to leave you with before maybe we open it up the last 5 minutes for questions, just a little bit of advice. So wherever possible, I think you should look for off-the-shelf models and start there and start to tune those models for the way you want to use them. As I mentioned, I think hardware gives a great advantage. So being able to do faster modeling, faster inferences is important. And so I would always choose where you have optimized chips. You always want to measure improvement along the way to make sure that you're going in the right direction. You will go off in the wrong direction on occasion, just back up. That's not a problem and start over. And then cleaning up your data. So garbage in, garbage out, as we all know, it's really important. In fact, I counsel most retailers, I think it's okay to do a few machine learning experiments here and there, small things, but if you're going to get serious about it, you probably need a data lake. You probably need a single source where all this data sits and it's very easily accessed. So that you can gain all those insights from all the different types of data, both structured and unstructured. Okay, with that, I think I'll turn things back over to Peter if there are any questions.
Yeah, definitely. Thank you, David, for that amazing and insightful talk. So we have a couple questions, and if you have any more questions, just type it in the chat and I'll ask David about it. But our first question is, does AWS help retailers with running experiments? So doing forecasting or optimizing?
Yeah, absolutely. We actually have a machine learning lab where we have dedicated resources that can work with a retailer and their specific data set, their specific needs to try and build custom models or to try things out. We do a lot of proof of concepts. We also do things like immersion days and training days where we can help train data scientists on how to use the tools, sort of teach a person to fish, they fish a lifetime. Absolutely willing to help in those areas.
Awesome. Yeah, it sounds like you guys have very tailored tools for it, depending on the business needs. So next question is a bit about the cold start forecasting and how AWS kind of helps with that.
Yes, so with Cold Start, you're starting with a brand new product that you've never forecasted before, so it's sometimes a little difficult. We look at the attributes of that product and compare it to the attributes of similar products. That way we can have a baseline forecast and then build up from there.
I see. Okay. So guess that's about it for the questions so far. And oh yeah, we got another one in. I guess it's a follow-up. What size of a retailer do you think machine learning starts becoming a useful or needed tool?
Good question. I tend to work with larger retailers, but I would say 100 million in sales per year and up is where it starts becoming very valuable. I think when you're under that number, you can focus in a lot of other areas. But low-hanging fruit, things like personalization are pretty easy to implement. When you use something like Amazon Personalize, it's a managed service, so it doesn't take a huge amount of effort to get that up and running. And I think you can really move the needle both on a website, for example, to do recommendations, but also in the marketing, if you're pushing out email marketing, to make those as relevant as possible. So kind of those managed services like Forecast or Personalize, Lookout for Metrics, a few others. Those are probably okay, 50 million and up. When it starts to get into any sort of custom things, probably 100 million and up is more likely.
Mm-hmm. I see. I guess a follow-up question to that is what sort of recommendations would you have for, I guess, the smaller companies or startups that are trying to enter the retail space?
Yeah, entering the retail space can be tough right now in this economy. So you want to do anything and everything you can to really embrace differentiation. Some things I've seen that have been really good, things like live streaming and combining that with something like recommendations. So very popular in Asia, and I think coming to North America, doing live streams. So it's kind of like home shopping through the internet. A lot of people watch these on their phones or they watch it on the website. But then as you're demonstrating products, you make it really easy to click on those products and add them, but you can also do recommendations. So if you use machine learning to make those recommendations, you can start to increase your sales, kind of get a bigger share of wallet.
Yeah, oh, that makes a lot of sense. I think it also seems like it's coming full circle too with the live streaming, because back then, on cable TV, there's usually the shopping network, and now it's even more convenient. Instead of back then, you had to phone in. Now it's just one tap, right?
Yeah, especially on mobile devices. And that's, as people have been less likely to go out shopping because of the pandemic, there's also a need for entertainment. So live streaming is entertainment plus shopping. I mean, who could ask for anything more? Yeah. And, like I said, adding those recommendations in there helps lift up the total size of the cart. Definitely.
All right. I think that's it for questions. So just before, we have one more question actually. Are there any models at Amazon that contacts multiple business units data within Amazon to create a holistic customer journey model?
Between business units. Well, so I'm from the AWS side, so I don't know on the Amazon side how they do that. We stay very firewalled. So I'm not really sure I know how to answer that question.
Okay, it's fair. Yeah, so that's about it for the questions. We're a bit over 2 minutes, so I'll just make a quick announcement. Wanted to let everyone know that the video for this talk and all the talks today will be available after we edit it, and we'll send it out. And lastly, we have a career fair coming up in June, and our annual ML Ops World Conference is also happening in June. Thank you so much, David, and thank you everyone in chat for joining us today.
Bye, everyone. Thank you.